In this video, we'll continue our discussion of section 2.3. I'm only going to do one example. There's a trick in here to get this one started. If I take a look at it, and I'm trying to make sure that it is first order linear, these are the same directions that we've been dealing with, find solution, interval, transient term. But I'm looking and I'm like, okay, there's a dp dt, there's my derivative. That means p is my function, and I have two of them. So right away, I'm like, that's not first order linear because I have that p on the right side, but you can actually manipulate this. This is dp dt plus, and I'm going to do 2tp, and I'm going to minus this p over. All right, but that still has a problem, right? There are two p's, but notice those two terms have a p. So we get 2t minus 1 times p. Multiply that out to make sure it's still right. Now it's first order linear. So mu is e to the integral of 2t minus 1 dt, not x this time. That's going to be e to the t squared minus t. All right, first order linear tells me I can go straight to the product times p, not y, right? Capital P. And then I have to multiply the other side. So we're going to have 4t minus 2 e to the t squared minus t. I'm going to go ahead and before we start integrating, no, I'll do it, I guess, as we go. E to the t squared minus t times p. And then do you see that this would actually be 2t minus 1? Same thing. So I'm going to pull the 2 out front, and then I'm going to have a t minus 1 times e to the, oh, actually leave that. I remember what happens. So we have the integral of 4t. Oh, no, no, I think, hold on. Let's go ahead and go forward with it. Okay, so I'm going to do a u sub. My notes. I have them right here. Perfect. Okay, so u sub, I'm gonna do t squared minus t. And then I want you to notice, oh, and I actually, that's why my brain froze, is I guess I can't factor. This is a 2 times 2t minus 1. There we go. Now it's right. Okay, so du is 2t minus 1. So it actually dt, but it actually covers that whole piece there. So for this next problem, I'm gonna have a 2 out front, and then I'm gonna integrate. This is taken by my du. So I'm just left with e to the u, du. Okay, that's e t squared minus t times p equals, and then I get 2, and then the same function comes out, t squared minus t plus c. All right. If I multiply now by the opposite of the t squared minus t, like I have the negative, then I cancel it there. Or I guess I could think about dividing. I get it just to 2, and then I'm going to get ce, and then it's going to be t minus t squared. I multiplied it by a negative, right? If I multiply subtraction by a negative, it makes it negative. It flips it, right? 5 minus 3. If I times that by a negative, oops. If I times that by a negative, it becomes 3 minus 5. They just flip. All right, so there's my solution. This is defined, I believe, everywhere. I don't see any problems. We didn't divide really at all. So this is negative infinity to infinity. And then actually this term right there is transient. May not be obvious, but if t gets bigger and bigger, that t squared gets big, much bigger than t, making that exponent a negative, which means it's on bottom, getting bigger and bigger, meaning it's going to 0. So there is my solution with the interval and the transient term.